Hello everyone, and welcome to the lab extension presentation. I'm going to go through this one rather quickly because we went over it in class and did it in class and it's meant to be done in class. But feel free to use the pause if you need to put stuff into your calculator and actually do this yourself. So, what we are going to do here in our lab extension is literally extend out our lab results. If you remember here, this is the cart rolling down the incline lab, in which we got a position time graph which was a parabola. And in a previous video called Instantaneous Velocity, you learned that in order to find the velocity, which we originally defined as the slope of a position versus time graph, we needed to find the slope of the tangent line to that parabola. The slope of the tangent line is the slope of the curve. So what we are going to do here in our lab extension is to look at what that tells us about the motion. Namely, we are going to create graphical and mathematical representations of the relationship between the velocity and the time for a cart moving down an incline. We're going to create a nice data table with time in seconds and velocity in centimeters per second. And I would want you to fill in the time column with the average times from the cart moving down an incline lab. And I'm going to now show you how, using a TI calculator, you can figure out the slopes of the tangent lines at all the average times you had in the lab. In other words, we're going to take one of the times, figure out the slope of the tangent line, and that is the velocity it's moving at. And then we will go back and graph velocity versus time and see what that tells us about the motion of the cart moving down the incline in a video cleverly called Lab Extension Post Lab. So, the first thing we need to do here is we need to enter our position math model from your lab. So find your calculator on here and push the button or buttons. The position math model we developed in the lab should look something like this. Right? This was the theoretical value. So this is actually right down here what you're punching into your calculator. You should have y equals your slope. Please don't use 85 unless that's actually your slope. X squared. And don't forget the squared. You leave off the squared, you'll have a linear graph instead of a parabola. Next thing we need to do is to set the graph window. This is kind of like auto scaling in LoggerPro so that we only see the part of the parabola that we want, the part that applies to the lab that we're doing. So, push the buttons, and then punch this in. This will basically size the graph, arrange it on the screen in a nice way so that you can see the part of the parabola we need. Remember here that x's are really times and y's are positions because we're making a graph of position versus time. So your minimum time was 0, your maximum time, put in a 1, your scale about 0.1, your minimum position, negative 20. It just helps it to see it better. Y max about 90 and your position scale 0.1. Next thing we need to do is to tell the calculator what we want it to do, namely to find the slope of the tangent line at a particular point on your graph. So punch these buttons. Most of you using an 83 and 84, graph, draw, which is second program, and then 5, which is tangent. When you push these buttons, you should end up on your screen with a top opening parabola, first quadrant, blinking cursor on the parabola. If you do, then you have set everything up correctly. And we are now ready to tell the calculator not only that we want it to find the slope of the tangent line, which we did by punching these buttons, but also telling it at what time do we want it to find the slope of the tangent line. And to do that, you simply need to type in your lowest time, not 0, but the next lowest time, and then press enter. What's going to happen here is that the calculator is very quickly going to do the limiting process described in the instantaneous velocity video, namely taking a second point, drawing a chord between the 2 points, finding the slope of that chord, which is the average velocity, moving the points closer together, drawing a chord through those 2 points, finding the average velocity, and continuing to move the points closer and closer and closer together until the calculator says, well, this is now so close that this is essentially the tangent line. And it will then tell you what the tangent line is, the equation of the tangent line. It'll draw it right on your screen and then tell you what it is. Now, if you're using an 86, it'll give you this and a number. This is essentially calculus speak for velocity. Okay? And so this would end up being the velocity would just be the number. For most of you, it's going to give you a y equals mx plus b form of your tangent line. And so if you take the slope off of there, right? The first number, the one right next to the x, that is your velocity. And you would type it in or put it into your data table for that time. So that's the velocity for that time because, as we talked about, the slope of the tangent line on a position time graph is the instantaneous velocity of the object. Now, once you get this one, you just need to do it again and again and again, 10 more times. And you do have to punch in these buttons again. The calculator won't remember what you want to do. You have to tell it what you want to do and then type in the next time. Let it draw the new tangent line, and then it will tell you the slope of the tangent line or the instantaneous velocity for you to record. Once you're all done, you go into the back of the room, you graph velocity versus time, and you're going to see if there's a relationship. And there most definitely is. So I hope you enjoyed learning how to use your TI calculator to find slopes of tangent lines.